All right, we're going to go ahead and start in chapter 10, which is all about radicals. So square roots, cube roots, fourth roots, all different types of roots or radicals. In 10.1, we're going to start off kind of simple, talking about what a root is, maybe a square root or a cube root. We're going to talk about simplifying those radical expressions and maybe even start to graph and talk about some domain restrictions. If you look at 10.1 with me, and we first start talking about square roots. When a number is multiplied by itself, we say that that number is square. So for example, 3 times 3 is 9. We say that that number 3 squared equals 9. If we can find a number that was squared in order to produce some value a, we call that first number a square root of a. For example, if I give you the square root of 4, what number multiplied by itself gave us 4? Well, 2 times 2. So that means the square root of 4 is 2, because 2 times 2 is 4. So when we have a radical, we're always talking about how many numbers does it take to multiply by itself to get to that number on the inside. When we have no number in front of that radical, it's called an index. It's really actually assumed to be the number 2. So if there's no number there, it's really a square root. We could have cube roots though, we could have fourth roots, we can have all different types of roots. And we'll talk about those a little bit later in a second. But that number on the outside of the radical there is called an index. The number on the inside is called the radicand. So let's look at a few examples and see if we can simplify some of these square roots. It looks like in example number 1, it's asking us to simplify all different types of square root problems. The first one asks us to simplify the square root of 25. So what we're looking for is what two numbers multiplied by itself give us the number 25. Well, if you think about it, 5 times 5 is 25. So that means the square root of 25 is 5. Now look at B. 25 divided by 64 doesn't quite go in evenly. We would end up getting some sort of decimal, and it doesn't reduce. But what we can do with a square root, if it's a fraction underneath and can't be divided inside, what we can do is we can actually break this up into smaller square roots. So instead of the square root of 25 over 64, I could actually do the square root of 25 over the square root of 64, breaking it up into individual square roots. So now, what's the square root of 25? What times what gives me 25? Well, 5, remember? And what's the square root of 64? So what number multiplied by itself gives you 64? Hopefully you said 8. So the square root of 25 over 64 is really reduced to, simplified to, 5 over 8. You notice that there is no more square root sign, right? Okay, so look at C. C says the opposite of the square root of 64. Well, what's the square root of 64? We said 8. What's the opposite of 8? Well, it's negative 8. You notice that the negative is outside of the square root. That's really important. Because if I changed it where the radical or the negative was underneath the radical inside the radicand, what number multiplies twice the same exact number to give you negative 64? Well, if you said negative 8 and negative 8, don't two negatives make a positive, not a negative? And if you said positive 8 and positive 8, then I would get a positive 64. So really, there is no number multiplied by itself to give you a negative number ever, 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 ever. So anytime I have a negative underneath a square root, my answer is no solution. There is no way that I can multiply two of the same numbers together and ever get me a negative. So make sure that the negative is outside of your square root, or else you have no solution. So make sure you're careful with that one. All right, look at D. We can have square roots of decimals. We just have to figure out what decimal multiplied by itself gives me the decimal 0.0049. You should end up getting 0.07. So the square root is 0.07. All right, let's look a little bit more about roots of numbers. In example number 2, it asks us to find the two square roots of 36. So what number multiplied by itself gives us 36? Well, maybe you said 6 and 6. So the square root of 36 is 6. But what about negative 6 and negative 6? Doesn't negative 6 times negative 6 also give me positive 36? So I could actually say that there are two square roots of 36, positive 6 and negative 6. So what about these numbers? What if I asked you for the two square roots of 9? Couldn't you say 3 and negative 3? Or the two square roots of 25, couldn't you say 5 and negative 5? So what about the two square roots of -4? What number, the same number, multiplied twice gives you -4? Remember, we can't have a negative square root. There is no number multiplied twice by itself to give you a negative number. So this one has no square roots. But 9 does, has two different ones, and 25 does, +5 and -5. Now, typically though, anytime I ask you for the square root, the square root of 25, the square root of 36, what I'm really asking you for is really just the positive square root of that number. It's also called the principal root. So anytime really we ask you what the square root of a number is, we typically only think about the positive square root. The square root of 25 is +5, the square root of 36 is +6, and so on. Okay? All right, last little example in this video is a little bit of function notation here with roots. It says here for each function, find the indicated function value. So we have f of x is the square root of 3x minus 2, and we want to find f of 1. Remember, our function notation f of 1 means that in our f function, we're going to substitute our variable, in this case x, with a 1. We want to find f of 1. So if our input is 1 and we plug in a 1 to our radical and simplify, what do we end up getting out? Well, 3 times 1 is 3. 3 minus 2 is 1. And what's the square root of 1? What number multiplied by itself gives you 1? That means f of 1 is 1. Let's do b. b says that we have g of z, which is negative the square root of 6z plus 4. And as long as that negative is outside, we should be okay so far. It's asking us to find g of 3. That means in our g function, we want to substitute in 3 for z. Let's substitute in our 3 and let's simplify. 6 times 3 is 18. 18 plus 4 is 22. I don't know if there's a square root of 22 though. I know there's a square root of 25, 5 times 5, but I don't think there's any number multiplied by itself, any whole number anyway, multiplied by itself that gives us 22. Now, we could punch this in our calculator and get a decimal, which would be fine if that's what it's asking us for. But right now, I don't know a whole number, an even root of 22. So I'm just going to go ahead and leave it this negative square root of 22.